So limits involving infinity, asymptotes of graphs. These are the topics we're going to discuss in this section. So first of all, let's look at this example here. In this graph, as x approaches to infinity, that means if you go towards the right side, or x approaches to negative infinity, if you go towards the left side, what happens to this graph? This graph goes down. It goes to 0. So this curve or the value of y approaches to 0. That is called limit at infinity. Either you go to the right side or left side, it's going towards some finite value, and that is actually the limit at infinity. Okay. Luckily, in this particular example, on both sides, it's going towards 0, but sometime it might go to two different direction. Okay, two different values. So what is limit at infinity? The limit of the function when x approaches to infinity. If it gives you some finite value, that's called limit at infinity. And this is epsilon delta type of, like precise definition of limit. The very same concept here we're applying for every number epsilon. If there exists a number m, capital M, such that for any x greater than m, the difference between the value of the function and L is always less than infinity, that's called limit. But I want you just to focus on this concept. This is nothing new. It's just the limit of the function when x approaches to infinity or negative infinity. If it approaches to positive infinity or negative infinity, when x approaches to positive infinity or negative infinity, if the value of the function approaches to some value L here, one more time, I'm using L for both of them, but it doesn't mean that it's supposed to be always same value. Okay, so all the properties of the limits we discussed before, that would be true either it's a limit at infinity or not. So whatever property we used before, limit when x approaches to some finite value, that is also true for when x approaches to positive infinity or negative infinity. So now it's time to define the asymptote. What happens when you find this limit at infinity? Y equal that limit is actually the horizontal asymptote for the graph. If you have a limit when x approaches to positive infinity or negative infinity, and that limit is equal to b, it's not necessary that it's supposed to be b on both sides, but if that is equal to b, then y equal to b is a horizontal asymptote of the graph of a function. I'm going to give you one example here. Let's say this is the graph of a function, and when x approaches to positive infinity, when you go to the extremely right, the graph approaches to 1. So y equal to 1 is horizontal asymptote. When x approaches to negative infinity, to the extreme left, the graph approaches to y equal negative 1. So that means y equal 1 and y equal negative 1 are two different horizontal asymptotes for the same graph. In this case, when x approaches to, let's say, 1, what happens to the graph? The graph goes to positive infinity from right side and negative infinity from left side. In this case, when x approaches to a finite number, the graph is approaching towards infinity. So this time, the limit itself is infinity. So whenever you try to find the limit of the function when x approaches to some finite value, if that goes to either positive infinity or negative infinity, that's called infinite limits. It's not limit at infinity, but it's called infinite limit. So in this case, it's a positive infinity, and maybe you have a negative infinity. So for epsilon delta, meaning it's a very same thing. So this is nothing different. It's just limits are infinite, either positive infinity or negative infinity. In that case, there is a particular name for that, and that's called vertical asymptote. So what is the vertical asymptote? When the limit of the function approaches to positive infinity or negative infinity, as x approaches to c, in this case it's 0 here, then that x equal to c is your vertical asymptote. So what is the vertical asymptote? a line x equal to a such that when x approaches to a from right side, this plus means from right side, or left side, either of them, it gives you positive or negative infinity, then that line is a vertical asymptote. In this example, as you can see here, when x approaches to negative 2 from right side, the graph approaches to positive infinity. That's why x equal to negative 2 is a vertical asymptote. When x approaches to negative 2 from left side, again the graph approaches to negative infinity. That's why it's a vertical asymptote. For the horizontal asymptote, when x approaches to positive infinity, if you go extremely right, the function goes to y equal to 1, and that's why it's a horizontal asymptote. So in that way, we can find out, you know, the horizontal asymptote and vertical asymptote, and they are very, very useful if you try to draw a graph for that particular function. So plotting the graph would be very easy if you can find out vertical asymptote and horizontal asymptote, which is not always possible to find, but whenever it's possible, it would be easy. And the one way to find that vertical and horizontal asymptote is finding the limit at infinity, or when the graph approaches to infinity as x approaches to some finite value. There is another example here. X equal to 2 and x equal to negative 2 are two vertical asymptotes because when x approaches to positive 2 or negative 2, the graph approaches to positive infinity. And then y equal to 0 is horizontal asymptote because when x approaches to positive infinity, the graph approaches to 0, and when x approaches to negative infinity, the graph approaches to 0. Okay, let's look at some examples here. Example, this one. Find the limit of the function 2 over x minus 4 as x approaches to infinity. This is very similar to this one. When x approaches to infinity, the graph goes to 0, or negative infinity, the 1 over x goes to 0. So in this case, when x approaches to infinity, 2 over this value x goes to 0, and then left over would be negative 4. So the limit would be negative 4. When x approaches to negative infinity, again, it's going to be the negative 4. Let's go to the next example here. Find the limits of the rational function as x approaches to infinity. Look at here. You can see the function. Okay, the function on the top it's a polynomial function with a degree 6. The function on the bottom, the degree 3. When x approaches to infinity, because of its power on the top, it's higher. It goes to the infinity faster than this one. That's why the value would be infinity. Okay, because the top part goes to infinity faster than the bottom part. We need to simplify, because if you look at on the numerator, when x goes to negative infinity, this is the even power. It takes the value to the positive infinity, and this is odd power. It takes value to the negative infinity. So there is a confusion, positive infinity over negative infinity. So we need to simplify this first. So how can we simplify? What we can do is we can just factor out highest power from the bottom, which is x cubed, and then we can do the same thing on the top, and then leftover we can write it down here, plus 5 over x minus 1 over x cubed. Similarly, this would be 6 minus 7 over x squared plus 3 over x cubed. Look at here, I just rewrote this. In that way, I can cancel this thing. And when x goes to negative infinity, this part goes to 0, 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 and only leftover part would be 9x cubed over 6. Because of the odd power here, When x goes to negative infinity, this expression goes to negative infinity because of the odd after cancellation. So the answer would be negative infinity. Okay, this is one-sided. When x approaches to positive 4 from right side, so this is the graph of the function look like. X equal to 4 is here, and anything greater than 4 would be like this. And x equal to 0, that would be like this. So okay, this is the graph of this function. When x approaches to 4 from left side, from here, the graph is going down. How do I know it's going down? Because just pick some values. If x is less than 4, then it would be negative, so it will go down here. It's a negative value, so the answer would be negative infinity. Negative infinity. When x approaches to negative 5 from positive side, as you can see here, this value goes to positive. This value goes to 0, but it will be positive because from right side means it would be, let's say there is a negative 5. From right side means this direction. So the value on this direction would be like, let's say, negative 4.9 or something like that. So if you put the value like negative 4.9 here, it would be positive on the bottom part, and it would be negative on the top part. So eventually negative over positive would be negative. So when x approaches to negative 5, because this value is going towards 0, it's like 1 over x. When x approaches to 0, what happens to this? It goes to infinity. Okay, if you approach from right side, but if you approach from left side, it goes to negative infinity. So here, because on the bottom part it goes to negative value, and on the on the bottom part it would be positive value and approaching towards the positive side, and on the top part it's approaching to it's the value would be negative, because when x approaches to negative 5, you replace x by negative 5. So eventually this value goes to negative infinity. So the answer would be negative infinity.